Welcome to an exploration of green chemistry, a revolutionary approach to chemical science and engineering. This field represents a fundamental shift in how we think about and practice chemistry. It is often referred to as sustainable chemistry, emphasizing its core mission. Green chemistry is both a philosophy and a practical methodology. Its primary focus is on designing chemical products and processes that reduce or entirely eliminate the use and generation of hazardous substances. This proactive approach aims to prevent pollution at its source, rather than treating it after the fact. The broader aim of green chemistry is to fundamentally rethink chemical processes. It seeks to minimize environmental impact across the entire life cycle of a chemical product. Ultimately, it strives to promote human health and well-being by creating safer chemical alternatives. This innovative discipline is guided by 12 foundational principles. These principles serve as a comprehensive roadmap for chemists and engineers worldwide. They provide a framework for innovation, driving the creation of a more sustainable future for everyone. One of the central tenets of green chemistry is waste prevention. This principle emphasizes designing chemical reactions in a way that maximizes atom economy. The goal is to ensure that most, if not all, starting materials are incorporated into the desired final product. By maximizing atom economy, green chemistry significantly minimizes the generation of byproducts and waste. This stands in stark contrast to many traditional chemical processes, which often produce substantial amounts of unwanted waste. Preventing waste at the design stage avoids costly disposal requirements. It also eliminates the potential environmental harm that can arise from hazardous waste. This proactive approach is far more efficient and environmentally sound than traditional end-of-pipe waste treatment methods. It represents a paradigm shift in chemical manufacturing. Another crucial principle involves the use of safer solvents and auxiliaries. Traditional chemical synthesis often relies on large quantities of hazardous solvents. These can pose significant risks to human health and the environment. Green chemistry actively encourages the use of safer alternatives. Examples include water, which is abundant and non-toxic, or supercritical carbon dioxide. It also promotes solvent-free reactions whenever possible, further reducing chemical footprint. This shift dramatically reduces the risk of exposure to harmful chemicals for workers and communities. It also minimizes environmental contamination, protecting ecosystems from persistent pollutants. Choosing benign solvents is a key step towards a cleaner chemical industry. Designing for energy efficiency is another vital aspect of green chemistry. Many chemical reactions require significant energy input, often contributing to greenhouse gas emissions. Green chemistry seeks to minimize this energy consumption. It promotes reactions that can occur at ambient temperatures and pressures. This reduces the need for heating, cooling, or high-pressure equipment. Lower energy demands translate directly into a smaller carbon footprint and reduced operational costs. By optimizing reaction conditions, chemists can develop processes that are inherently more sustainable. This focus on energy efficiency is critical for mitigating climate change. It also makes chemical production more economically viable in the long run. The use of renewable feedstocks is a cornerstone of green chemistry. This principle advocates for shifting away from finite resources, such as petroleum, as raw materials. Instead, it encourages the utilization of sustainable and renewable materials. Biomass, derived from plants and other organic matter, is an excellent example of a renewable feedstock. By using such materials, green chemistry reduces our dependence on fossil fuels. This move is essential for long-term environmental sustainability. Embracing renewable feedstocks also promotes a circular economy. Materials are sourced from regenerative cycles, minimizing depletion of natural resources. This approach ensures that future generations will have access to the resources they need. The advantages of adopting green chemistry principles are far-reaching and profound. It leads directly to the creation of safer products for consumers and industries alike. These products are designed to be less toxic and more environmentally benign throughout their life cycle. Green chemistry significantly reduces pollution across various stages of chemical production. By preventing waste and using safer materials, it minimizes emissions into air, water, and soil. This proactive approach safeguards ecosystems and public health. It also plays a crucial role in conserving valuable natural resources. By maximizing atom economy and utilizing renewable feedstocks, green chemistry reduces the demand for virgin materials. This contributes to a more sustainable use of our planet's finite resources. Furthermore, green chemistry promotes economic efficiency. Preventing waste reduces disposal costs and the need for extensive pollution control measures. More efficient reactions and lower energy consumption also lead to significant cost savings for industries. Green chemistry is absolutely vital for building a truly sustainable future. It is indispensable for protecting human health from the adverse effects of hazardous chemicals. By designing out toxicity, it creates a safer living and working environment for everyone. It is equally vital for protecting the environment from chemical contamination and degradation. Green chemistry offers solutions to many pressing environmental challenges, from water pollution to climate change. Its impact is felt globally. This transformative approach is already revolutionizing various industries. In pharmaceuticals, it enables the synthesis of medicines with fewer toxic byproducts. In plastics, it drives the development of biodegradable and bio-based materials. Green chemistry is paving the way for a cleaner, healthier world. It empowers chemists and engineers to innovate responsibly, creating solutions that benefit both people and the planet. Embracing these principles is not just an option, but a necessity for our collective future.